Okay, now we will look at the new study that a friend of mine sent me. Oops. Okay, I think I'm running here. Evidence of negative time found in quantum physics experiment. Now this is very similar to Günter Nimtz's superluminal acoustic signal experiments, revealing observational evidence of negative time. And the person who sent this to me said that I called it. But if we go to the paper, it's basically necessitate a reinterpretation of the physical meaning of group delay in optics. So when we go to the paper, this is how the paper ends. While it is widely known that the group delay can take on negative values associated with the peak of the transmitted portion of a pulse, appearing at times which may indicate superluminal or negative group velocities, it is commonly argued that this quantity does not correspond to the time anything actually, quote, spends in the medium, but merely to the happenstance of when interference is predominantly constructive. Our observations, however, show that the group delay is a physically meaningful quantity. It not only provides a location of the center of a transmitted pulse, but also correctly describes the magnitude and sign of the effect transmitted photons have on other systems they interact with. So that's a very complicated, sophisticated result. But if we look at the here's the actual group delay, and then here's the signal. So this is why it's superluminal, is because the group delay is negative compared to the signal, which is ahead. And so you end up getting a interference pattern that's time reversed from the future. Now, if we go back to the article, they say, even though the phenomenon is astonishing, it has no impact on our understanding of time itself. And then it says that if you had a quantum clock to measure how much time atoms are spending in the excited state, the clock hand would, under certain circumstances, move backwards rather than forward. In other words, the time in which the photons were absorbed by atoms is negative. Now, here's the key part. It says, the photons aren't communicating any information, so the outcome does not contradict the, quote, nothing can travel faster than light speed limit set by Einstein. Well, that's very much true if you're having a physical experiment, but what about if you're meditating with biophotons? And so the photons are directly the information without any external measurement, in which case you would get the time reversed signal that does have information, and it is physically meaningful. It's not just mathematical, as this experiment proves. So once again, if we consider quantum biology, then it is actually information directly, and this is what Olivier Costa de Beauregard argued, explains the paranormal and spiritual phenomenon is you have this time reversed or superluminal negative signal. Of course, he was relying on relativity, the invariance principle itself, creating a contradiction with quantum physics, which is what Louis de Broglie originally discovered with his law of phase harmony. So the photons can make atoms seem to spend a negative amount of time. Now, the other thing to realize in quantum biology, as Gerard de Hooft and Martin van der Mark explained, is that based on the Louis de Broglie's law of phase harmony, matter itself is made of photons. The photons seem to exit a material before entering it. So, if we go back to the paper, they have, it's a complicated experiment. So, unlike expectation values, weak values are not restricted to be within the eigenvalue spectrum of the operator being measured and can even be complex. So that's where you get the imaginary negative frequency and time reversed signal, because it's complex. And what Basil J. Hiley explains is that this is due to the non-commutativity of non-locality itself, so that before matter exists as a particle, you already have this complex or non-commutative negative frequency and time reverse non-locality of basically the future and the past overlapping, and it's instantaneous, and it's before any sort of statistical analysis that would be the basis for relativity out of quantum physics. And so that's why they call it active information from the future. And the other thing is that basically it's like holographic, so it's what they call hollow movement. And so you have the position and the momentum are holographically non-local and embedded in each other. And this is before any measurement takes place. So before you even have zero time, or at zero time, you already have this non-commutative hollow movement of the future and the past overlapping. And that's why they say, it's a photon emission or a photon absorption. That's superluminal, and it's physically exists. That's what this experiment proves. So here they have the difference between the time signals between the group value or the data. So the expected value is the orange, and then the actual experimental data is the blue. And anyway, So I think I already read this. The results depicted in Figure 3 undeniably raise the question, what does it mean for an atom to be excited for a negative time, or equivalently, for a photon to spend a negative amount of time as an atomic excitation? The theory work in 19 shows that the atomic excitation time due to a transmitted photon is equal to the group delay given a single photon input. Additionally, it provides an illustrative explanation of how this time can be negative, discussing a similar system in which anomalous dwell time arises from quantum interference in a cavity. I guess, yeah, I did not read that yet. It turns out that it's also possible to leave aside calculations of the weak value of excitation time observables entirely and make a direct prediction for the correlation between the probe phase and the number of transmitted signal photons, which is what we measure experimentally, at least in the limit of single-mode signal and probe beams. And then they go into the math. This demonstrates that a phase shift is also induced on the transmitted signal. This indicates that the phase shift on the probe induced by a transmitted photon of the signal as measured by our experiment is proportional to the group delay with a scaling factor. Yeah. Suggesting that the group delay governs other effects in regimes where its meaning may be less apparent. Exactly. That's where the mystery comes in. I want to see if they quote, see, this Raymond Chow paper is actually a debunking of Günter Nimtz, or it probably critiques Günter Nimtz. But this paper here actually corroborates Günter Nimtz. So that's why I sent it off to Günter Nimtz. And here we have Aronhoff. Okay, closing it out.